Right, we're going to go for number 26, an easy problem, removing the duplicates from a sorted array. So what we're going to probably do is create a new array that is from the old array. Actually, you know what we'll do? We're going to use the same array. Here's what we'll do. So given an integer of array nums, sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. So we'll just need to return the number of unique elements. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the unique elements of the order in which they are present in nums initially. The remaining elements of nums are not important, as well as the size of nums. And then we'll return k. So we'll skip that portion there. Essentially, our input will be nums of 1, 1, 2. All we need to do is essentially what we're doing is we're returning the number of unique elements to be k. We're not changing the size of the array. So we'll assign 1 to the first index, and then since 1 is the second index here, we're not going to count that one, but we will count the third index and assign it to index 2. And then what we can do is if we can return the max index number, or the number of indexes that are there, that are present, from the array. So the output would be 2. Same here, we got a bunch of non-unique numbers, putting them into unique numbers, that should be 5. It outputs 5. So we're going to just do a pass through once of this array using a loop. So I'm going to instantiate an index first. This index will represent the k that's talked about in the problem. Excuse me. So at the beginning, there's going to be one index. So index 0 of the array, there will be one number of indexes in there. Once we do that, we can dive into a for loop to loop over the array using 1 as the starting index. So we'll just go to the nums.length, and then we'll increment our counter. And then we'll do a conditional statement that essentially just says if the next number is the same as the current number that we're on in the index, then we won't assign it. But if the number in the index is not equal to the previous number, then what we'll do is add it to that index, or I guess add it to your reassign it into this this array here, and then we'll just increment the index to the next pointer in the array. So we'll show you what that looks like. So this is an if statement. So if nums sub I, which is the counter of our for loop, is not equal to the previous index in the array. So nums sub I minus 1. If those are not equal, then what we'll do is that means it's unique, and we're going to assign the index, which is 1, to the nums sub I. And then we'll increment our index that we instantiated at the beginning. And then at the end, all we need to do is return how many indexes there are, unique indexes. So we'll just return index at the end. So we'll count each time it goes through. So we'll run that. and it passes. And since it's only passing through once, has to pass through each individual piece to understand which ones are unique. This is an O of n operation in time complexity. So let's submit it, make sure it passes all the tests. And it does. And it does fairly well. So that is the solution for number 26.